All right, sixth grade friends, graphing the data today, graphing linear equations. The first part of what you're going to have to do is graph these charts, and they're going to give you all the ordered pairs in a chart. Okay? So the first thing you want to understand is making sure that you understand how to read these tables in the ordered pairs. Remember, ordered pairs, when we graph them, are the x-coordinate left to right first, y-coordinate up and down second. Input is x, output is y. We've been talking about that on previous assignments. And so it's saying when x is 1 and y is 0, the ordered pair is going to be 1, 0. When x is 3 and y is 2, the ordered pair is going to be 3, 2. When x is 5 and y is 4, the ordered pair is going to be 5, 4. When x is 7 and y is 6, the ordered pair is going to be 7, 6. So now, I'm going to put my marker cap back on. Now I'm going to take these ordered pairs and graph them on the graph. So I'm going to use this graph right here. And I'm going to have those ordered pairs. The first one is 1, 0. So remember what I do here. I'm going to try to zoom in as close as I can here. So here's the 1, and then I don't go up any. So my line is going to go right there at 1, 0. My line is going to go through that point. That's the first point that I use. My next ordered pair is 3, 2. Okay? So I'm going to go over 3, and I'm going to go up 2, and my next point is going to go right there. My next ordered pair is 5, 4. So I'm going to go to my graph. I'm going to go over 5. I'm going to go up to 4. Okay? So over 5, up 4, and my point is going to go right there. Okay? My last ordered pair is 7, 6. So I come over to my graph. I'm going to go over 7. I'm going to go up 6 to right there. So I'm going to go ahead and make that point. And then to actually make the line, what I do is then you're going to need to take a ruler or a protractor or something and connect them. I just can't connect them and make a line at the same time and hold my camera and everything else. So you'll see how I kind of connect them. But I will be expecting you to use a ruler or the side of a book or the edge of a protractor or something and make sure that your line is straight. Okay? So that's what we're going to want to do. So that's the first part, where it's just going to give you a table. You have to figure out what the ordered pairs are. You make your line. All right? And what I expect you to see is this line. So I'm going to see a lot of graphs and things uploaded on Google Classroom. Now, the second part of what you're doing tells you to graph the function. It already gives you an equation. It's a linear function. As you get into 7th grade next year, you'll talk about slope-intercept form and all sorts of stuff. And that is an absolutely beautiful thing. Beautiful thing. All right, graph the function. It just says, here's the equation. We want you to graph it. Well, what in the world does that mean? That basically means that you have to come up with the ordered pairs yourselves. Okay? Remember that the ordered pairs are x, y. You put something in for x, solve the equation to figure out what y is going to be. Now remember that you're going to need to look at your graphs, and you're going to have to find numbers that will actually work. Remember, you go as high as 10, as low as -10, up 10 here, -9 or -10 down there, all the way to the end. So you want to use numbers that actually make sense. You don't want to get numbers on the graph where you're like, well, x is 400 and y is 404, because 400 plus 4 is 404. You don't want to do that. Use smaller numbers that are easy to work with that will actually fit on the graph. So I'm going to go pretty basic, and I'm just going to say, well, I'm going to say that if x is 0, 0 plus 4 is 4. Y would be 4. Now, 6th grade, I want you to stop and think for a second. Because some of you are probably thinking, well, how many ordered pairs do I have to do? Well, Mr. Swack does not want this to be overly burdensome for you here today. So if you stop and think about it, how many points would you need to make to actually create a line? How much would you need to actually create a line? That's right, 2. As long as you have 2 points and then you connect them, you have a line. For example, let's just pretend that I have a graph here. In fact, I'll even put the arrows here. All right, let's just imagine that I was creating a graph and I plotted 1 point right here and I plotted another point right there, just 2 points, but guess what? That's enough to make a line. You only need 2 points to make a line. So one of my points is going to be 0, 4. But I want to keep it slow, or the number's low. All right, so I'm going to say, well, why don't we, so since our numbers are like 10 and negative 10, let's say I'm going to make x 3, and 3 plus 4 is 7. So one of my ordered pairs is going to be 3, 7. Well, let's go to our graph. All right, here we have our graph, 0, 4. So when x is 0, y is 4. And I'm going to go ahead and I have that point right there. All right. Then my other point is 3, 7. When x is 3, y is 7. So I'm going to come over here to my graph. Here's 3. I'm going to go all the way up to 7. And so I have 0, 4 right there, 3, 7 right here. You would actually need to use a straight edge, okay, to connect those lines. But I'm just making them the best that I can. And there you have a line. All right? That shows my 0, 4, 3, 7, and that is the graph of that line. It would keep on going forever in both directions. With many different solutions, we could just go all day plugging in different numbers for x, adding 4 to it, and getting y. Let's go to our next one. Here's something a little different. Y is 2x minus 5. Y is 2x minus 5. So I'm going to have to multiply 2 times x, 2 times something, but then I'm going to have to subtract 5. Well, let's say that I want to make x 1. So I can do a little scratch work here. 2 times 1, whatever that is, minus 5. Well, 2 minus 1 is 2. So this is going to become y equals 2 minus 5. Okay? And then, well, 2 minus 5, that's going to be a negative number, but I know that I can just switch the 5 and the 2. 5 minus 2 is 3, so 2 minus 5 must be negative 3, which means that when x is 1, y is negative 3. And one of my ordered pairs is going to be 1, negative 3. Well, let's try another one. Let's just say, okay, I want to make x 6, and I'm going to plug it in for 6. So that's going to tell me that y equals 2 times 6 minus 5, because y equals 2 times x minus 5, and x is going to be 6. Well, 2 times 6 is 12, so y equals 12 minus 5. And if y equals 12 minus 5, y equals 7. So that tells me that when x is 6, y is 7, and my other ordered pair is going to be 6, 7. All right? So now I have enough to make a line. 1, negative 3, 6, 7. So let's go to our graph. Here we have a new graph here. The first one is 1, negative 3. So it's 1 on the x-axis, but I'm going to go down this time because it's negative 3. Negative 1, negative 2, negative 3. So 1, negative 3 is going to go right there. And I'm going to have to plot that point. My other ordered pair was 6, 7. And you'll remember way back when we plotted ordered pairs. We've done that before, so that's not a new skill. But it kind of shows us why that's an important skill. You're going to be doing a lot of this kind of graphing of equations as you get into 7th and 8th grade. Graph paper is going to be something that you use quite a bit of. So when we go to 6, 7, we're going to go over 6 to here. We're going to go up to 7. So that's going to be right there. So now I have my 2 points. And of course, you're going to want to use a straight edge. But I'm going to do my best here just to kind of sketch a straight line, but like I said, I really want you just using a ruler or the edge of a book or a protractor and making a very nice, clean, straight line. But that's not too bad. And you see I put the arrows because they are lines. The idea is that they keep going forever in that direction. All right, so we have one more we're going to do. And this is a little interesting one. Y equals 3 over 2 x plus 1. So that's kind of an interesting thing. And so essentially 3 over 2, if I were to simplify, if I were to turn that into a mixed number, 2 can go into 3 once, so I end up with 1.5. If I were to take 1.5 and turn it into a decimal, well, I know that if I want to turn a fraction into a decimal, I divide. That would be 1 divided by 2. Well, I can't take 2 into 1, so it's going to be 2 into 1.0. Put my decimal straight up. 2 can go into 10 5 times. And I know that 5 times 2 is 10. There's none left over. So 1.5 would equal 1.5. You might find that a little easier to work with. Okay, 1.5x plus 1. So let's just try some different ones here. Okay, let's say that I want x to equal 3. So it's going to become y equals 1.5 times 3 plus 1, because x is going to equal 3. All right, so I've got to do 1.5 times 3. Well, if I come down here and do 1.5 times 3, 3 times 5 is 15. Put the 5 down, carry the 1. 3 times 1 is 3, plus 1 is 4. There's 1 digit after the decimal in the problem, so there's 1 digit after the decimal in the answer. I get 4.5. So when x is 3, y is 4.5. So one of my ordered pairs is 3 and 4.5. We'll talk about how to deal with decimals, putting them on our graph. All right, so let's just come up with another one. Let's say I want x to, well, before we forget, hold on. 1.5 times 3 is 4.5, but I need to add the 1. I almost forgot to add the 1. That's something that Mr. Swack would have done back at school. 1.5 times 3 is 4.5, but it says plus 1. Well, 4.5 plus 1, remember, do not do this. Don't do that. Remember, the 1 is going to line up with the 4, so it's going to be like 4.5 plus 1. It's going to be 5.5. So I'm going to get rid of that 4 there. Our y value would actually be 5.5. All right, let's give ourselves a little more room here. All right. We've already talked about how the 3 over 2 is the same as 1.5. We've already plugged in 3 for x. Let's say now we want x to be, I don't know, 6. Let's say we want x to be 6. So it's going to be 1.5 times 6 plus 1. So once again, I'm going to have to come over here. 1.5 times 6. 6 times 5 is 30. Put the 0 down, carry the 3. 6 times 1 is 6, plus 3 is 9. Don't drop the decimal, but how many ever digits comes after the decimal in the problem, that's how many need to come in after the answer. So I get 9.0, which is just 9. I need to remember to add 1. 9 plus 1 is 10. That tells me that my other ordered pair is 6, 10. And you'll notice how I was choosing numbers that fit on the graph. Okay, you don't want to get these big numbers. Use smaller numbers. Don't be afraid to use negative numbers. We came up with a negative number in the last example with our 1, -3. You've got room on the negative sides. Use it. All right, so my two ordered pairs are 3 and 5.5. So I'm going to go to my graph. 3, 5.5 is my first one. So I'm going to go over to 3 and I'm going to go up to 5.5. Well, remember, 5.5 is just going to become between 5 and 6. So it's going to be halfway between the 5 and the 6, which means with the 3, it's going to go right there. It's not actually going to go on a line. And sometimes that happens. And as a 6th grader, you can handle that. The other one is 6, 10. So I go over here to the 6 and I go up to the 10. The 10 is all the way up here, so I'm right at the very edge. 610. Once again, I want you to use a ruler or a straight edge of some sort, but I'm just going to do the best that I can, signifying that this line will continue to go forever. And so I am looking forward to seeing all of your graphs, 6th grade. Graphing functions, graphing the data in the table. All right, we'll talk to you later. Bye.